Further discussion continues here with oxidation and reduction reactions. We're going to go into describing how we identify oxidation and reduction reactions, but more specifically, which species are oxidized or reduced. This is section 7.7 in the chapter, and what things are oxidizing agents and reducing agents. It's completely related to understanding our oxidation numbers from the previous discussion. So this section might also be described in terms of describing things happening in redox reactions, identifying what things are oxidizing agents, reducing agents, and which things undergo reduction and which things undergo oxidation. All right, so the oxidizing agent causes oxidation because it gains an electron, at least one electron. And so an oxidizing agent undergoes reduction. This feels really tricky and kind of backwards, so you've got to be careful. So something that gets reduced has a decrease of its oxidation number from the start to the finish in a reaction. The reducing agent is something that causes reduction, and just like the oxidizing agent causes oxidation, but reduction means gaining electrons, right? And oxidation means losing electrons. And so if you're an oxidizing agent, it is able to gain or pick up electrons from something. A reducing agent, by contrast, causes reduction. Therefore, it has to be able to lose electrons, at least one. And so the reducing agent is that substance which undergoes oxidation. Oxidation means losing electrons. Reduction means gaining electrons. So be careful in how you think about those things. When something is oxidized, the oxidation number, so it's being oxidized, the oxidation number increases. So reduction, this is the one that I hang on to the most. The reduction is the process where an oxidation number decreases. That makes sense. Reduction and decrease of an oxidation number follows hand in hand. So where are these things on the periodic table? In a general sense, you can kind of make some patterns, see some patterns. Oxidizing agents are tending to be the things that will gain electrons. They cause oxidation to occur, and they're the things that tend to gain electrons for reasons like electron affinity. And so those are going to be nonmetals. Surprise. And in a general sense, that's what we expect. The opposite is also true. Reducing agents are going to be things that lose electrons easily because they will provide them to something to cause reduction. And so metals, in a general sense, are going to be reducing agents. Doesn't always get the right answer to every example, but these are good generalizations. So what we need to think about is how you recognize an oxidizing agent and a reducing agent. So reducing agent provides electrons to something that can get reduced. And so if it's going to give it to something else, then that substance becomes reduced. And the oxidizing agent is that which receives electrons, picks up electrons, allowing something else to become oxidized. And this funny little cartoon may or may not help you, but it's one way of thinking about it. I thought the cartoon was worth a try. So here's a simple reaction of magnesium with HCl. Which reactant is gaining and which is losing electrons in this context? So think about it in a simplistic way, remembering oxidation numbers are like charges. And so let's look at the oxidation numbers in these examples. And in this case, magnesium is an element, so its oxidation number is 0, and hydrogen and the products is also an element, so its oxidation number is 0. And without going any further, let's look at the magnesium in the product. Magnesium is now an ionic compound with magnesium chloride, and so its oxidation number is +2. The halogen chlorine, the chloride ion, is going to be -1. And if we go back and fill in on the reactant side, it still works because chloride ions in HCl should be -1. And hydrogen should be +1. So which one is losing electrons? This is like an example with magnesium and oxygen that I described earlier. And so in order to become a cation, magnesium has to lose electrons. So magnesium loses electrons to become a cation. And then what else has to change? Well, apparently the chlorine did not change, so it's not part of this process. And by contrast, the hydrogen ions will gain electrons and they become neutral atoms in the hydrogen molecule. And so losing electrons, that would be the substance which gets oxidized. So gets oxidized, and the hydrogen atoms are getting reduced. Hydrogen ions say that it gets reduced. Apologies, I hear some audio difficulties here. I hope that's not causing bad things on the recording. Okay, let's look at more examples. There's a lot more ways to talk about these things. We're not done yet. So if we think about these things, we're going to figure out which ones are going where. If calcium is reacting with hydrogen ions, what is being oxidized and which is being reduced? So calcium is going from a neutral atom to a +2 cation. It's losing electrons, so it's oxidizing because its oxidation number is increasing. It lost electrons, and therefore it is, when it's oxidized, it is the reducing agent. The converse must also be true. Hydrogen ions are having their oxidation numbers reduced from +1 to 0. And so that would be an example of reduction. The hydrogen ions are getting reduced, or it's gaining electrons, and they get reduced from +1 to 0, and so that's the oxidizing agent. The ones at the bottom of the screen are not labeled, so we'll have to think our way through them. So iron is going from +2 cations with an oxidation number that corresponds at +2 to +3 cations. So the iron is losing electrons to gets oxidized, and that makes it a reducing agent. The opposite must be true. Oxidation always pairs up with reduction. If the electrons are lost somewhere, they're gained somewhere else. And so in this case, the chlorine molecule has to be gaining electrons. The chlorine atoms gain electrons, and that means that they are getting reduced. And if you go from 0 to -1, that's a reduction of the charge. No kidding, 0 to -1, that fits. And getting reduced, whoops. And so this would be the oxidizing agent. Remember that fits from the generalizations on the periodic table. Oxidizing agents tend to be nonmetals, and reducing agents tend to be metals. You only describe these things in terms of reactants. You need the products to know how the changes have emerged or what result, but only the agents are always reactants, one way or the other. So here's some other examples. Let's see what's cooking. We have iron reacting with oxygen to make iron 3 oxide. Let me guess, we've actually seen this one before, but let's talk it through one more try. Iron is going from an oxidation number of 0 to +3 because you start as elemental iron, and it turns into iron as a cation. And so from 0 to +3, you're increasing the positive charge. You're increasing the oxidation number. Oxidation number increases. That means it has to lose electrons, losing electrons, and that means it gets oxidized. By comparison, your oxygen has gone from 0, an oxidation number of 0, to -2, so it is gaining electrons. It gains electrons. That would be gaining electrons is getting reduced. So which one is the oxidizing agent? Is the one that gets reduced. So oxygen is the oxidizing agent. Oh, surprise. Well, oxygen should be an oxidizing agent. And so the reducing agent is the one that gets oxidized, and so the iron is the reducing agent. Remember back to simplistic definitions. When iron gains oxygen, it is getting oxidized, and that fits here. Gaining oxygen is another way of saying getting oxidized. So the iron undergoes oxidation, and so the oxidizing agent is the one that undergoes reduction, namely the iron. Wait a minute. Sorry, I said it backwards. Try again. The oxidizing agent is the oxygen that undergoes reduction, and the reducing agent is the iron that gets oxidized. Wow, be careful how you say that. It's really easy to say it sideways without noticing. Let's try another example. Okay, how about the iron 3 oxide combining with carbon to return its elemental iron, and carbon dioxide is left over. So here we have to think about oxidizing and reducing agents again. So the iron is going from 3 to 0. It is reducing the positive charge, reducing the oxidation number, and that means it is getting reduced. But that means, reduced. And what else is shown here? Well, the carbon is going from, the oxygen does not change, by the way. So oxygen is not neither an oxidation, it neither gets oxidized nor reduced in this case, neither. So the carbon is the other element of interest. The carbon goes from 0 to, sorry about that. Let me see if I can reduce that distracting line for one moment. So here the carbon goes from 0 to +4, and that means that the oxidation number is increasing. The oxidation number, when the oxidation number is increasing, that means it's getting oxidized. Well, that fits too, because in this example it gains oxygen too, doesn't it? So if it gains oxygen, that's a giveaway that the carbon is getting oxidized. So the thing that gets oxidized is the reducing agent, and the thing that gets reduced is the oxidizing agent. So that would be the iron is the oxidizing agent because it provides the oxygen, and it's that which gets reduced, and the oxidizing agent is iron. Be careful, make sure that's clear to you. The reducing agent then is the carbon, and that is because it is gaining the oxygen, getting oxidized. All right, so here's another set of examples. If you add oxygen to iron, it's called rust, and it's a redox reaction. The iron is picking up oxygen, and it changes its oxidation states from 0 to 3. Here's a few other examples. Let's see which one is not oxidation reduction reaction. Well, let's sort these out, and we'll see if we can classify any of the other ones. Well, let's see which ones are oxidation reduction, and let's identify them as we go. So reaction number 1, magnesium turns from an element into a compound. It's going from a 0 to a +2 cation, and so that would definitely be redox. So this isn't the one that we're looking for. The next example is carbon in the form of methane reacting with oxygen to make CO2. And so in this case, carbon is gaining oxygen. Sure enough, carbon is gaining oxygen, so that's again redox in the simple sense without doing oxidation numbers. But you could. In this case, carbon is going to be -4 because hydrogen's +1. And in the product, carbon is going to be +4. How's that for different? So it's redox for sure. You're gaining oxygen, that's a clue. The next example, tin 2 oxide is reacting with carbon, and so it must be tin 2 with a +2 oxidation state, turns into tin element. Oh, well, that's again changing from ion to element. That's apparently losing electrons. Oops, sorry, gaining electrons. The tin is getting reduced by the carbon. In this case, the carbon gets oxidized. Carbon goes from 0 to +2 in this example, in redox context. Then the next example, silver ions reacting with copper. Elemental copper, silver is apparently going to have the same oxidation number as its charge. The copper will have the same number as its charge. And now the copper has turned into a cation. And so this would be an oxidation of the copper. Gets oxidized, gets reduced. So the silver does the opposite. It gets reduced and reduced to silver metal because it now has an oxidation number of 0. So again, another redox example. I probably should put some other or label the other ones in there, but let me finish this example. So apparently the last one must be the one that is not an oxidation reduction reaction. Why not? Well, you have two aqueous substances combining, and we're making aqueous ions and water. Oh, this is a base plus an acid. Oh, we should recognize these two. So acid plus base, we call this a neutralization reaction. Doesn't matter which acid, which base, but this is one combination that's possible. To make clear, let's verify what else is happening here. The magnesium on the first one is getting oxidized, gets oxidized. And that means that the hydrogen here is getting reduced because it's going from a +1 to a 0. Sorry, I didn't write the charge, or I didn't write the oxidation number in for you before. Getting reduced because the oxidation number is +1 in water and 0 as elemental hydrogen. The next example, I didn't write it in completely, so let's finish doing it. The oxidation number of oxygen better be 0, but in the product, it's going to be -2, and so it's gaining electrons. So the carbon gets oxidized, and that means the oxygen gets reduced. Oxygen gets reduced. The third example, the tin is going from a +2 to a 0. It's being reduced. Tin is getting reduced. Its oxidation number gets reduced. And that means that the carbon is becoming oxidized. Well, sure, it picks up oxygen. Gets oxidized. That fits in this example. And I already labeled number 4. Good practice. Okay, more examples the merrier. I hope you find these helpful. If you don't choose to watch them all, that's your call. Here's another set of the possibilities here. So methane burned in oxygen. The product containing the carbon atom is carbon dioxide. We call this combustion. The oxidation numbers of the carbon atoms in methane and carbon dioxide respectively are what? Well, we need to think them through. I actually think I may have showed you this on the previous slide, but let's make sure we see them. The oxygen is the easy one because oxygen is elemental oxygen. So it is nothing but 0 for the oxygen, but we have to figure out what the carbon is in the two different cases otherwise. Well, then, let's figure out what the hydrogen should be with the carbon in the first one. The hydrogen is normally going to be +1. And so in this case, carbon has to be enough to add up to 4 of the +1. So carbon has to be -4 in this one. So only one of these choices makes any sense. In the result, make sure that that makes sense. Oxygen better be -2, but there's 2 of them, so carbon should be +4. All right, that fits. One more example. See if you can follow along. This one looks far more interesting. This is something to do with a battery. And looks like a cutaway view of a battery where you've got manganese dioxide and carbon and ammonium chloride and zinc chloride. And what's going on in this battery includes the manganese 4 oxide right here, the zinc, and the products are going to be other things like zinc 2 oxide and manganese 3 oxide. Well, so which compound is the reducing agent in this equation? The reducing agent is what gets oxidized, aka that means it's going to loses electrons. So if you're looking at these things by oxidation numbers, that'll point you in the right direction. So zinc is going to be 0 in the start because it's an elemental zinc. And then in the product, zinc is going to be with -2 oxygen, so that means zinc is +2. There's your clue. So zinc is going to be getting oxidized because it loses electrons. And what else is changing? The manganese is, because in this first one, the manganese is +4, because oxygen should be -2. 2 minus 2 goes 1 plus 4. In the product, oxygen doesn't change very often, to be honest. You don't have to look for that. So 2 manganese and if you remember the formula, this was manganese plus 3. So in this case, the manganese is getting reduced from the manganese 4 oxide to manganese 3 oxide. And so that which gets oxidized, because it loses electrons, is going to be our reducing agent. And so it is the zinc in this example. All right, enough of these examples for this recording. I hope this is helpful to you on your homework. Please ask more questions as needed. See you in class.